So in this question, we're going to find the inverse Laplace transform of these four functions, as, bs, cs and ds. Now you'll notice they're all of the form of some sort of constant in the numerator, and in the bottom we've got s plus or minus, and then it's factored into the nth order. So here we've got a 5, a 3, a 4 and a 3. So these will not require partial fraction decomposition. These ones require a generic formula. So the generic formula for these are the inverse Laplace of c over s minus a to the n. So all of these take that kind of form. This leads us to c times the inverse Laplace of 1 over s minus a. So that's our first part. So we take the constant out and we need to know what this is. And then these are all multiplied. And then the next inverse Laplace of 1 over s to the n. And then our generic result, when we do this, so we're using our c, s, a and our n throughout. This gives us c times e to the a t, and then t to the n minus 1. So that's where our n will come in. And then this is all divided by n minus 1 factorial. Okay, so now using this, let's break all of these apart. Let's look at this one first. This one looks the most simpler of a case. So 1 over s minus 3 cubed. So what are our values of our variables? So here our c equals 1. A will equal 3, and our n here is also 3. Okay, so now our generic result will yield this result here, c times e to the at, so that's 1 times e to the 3t, so we've got e to the 3t, and then t to the n minus 1. Well, n is 3, so that gives us t squared, and then n minus 1 factorial. So that's 3 minus 1 is 2, so that's 2 factorial. So we can rewrite this, if we like, as t squared e to the 3t over 2. So that's the answer I would declare for this one. Now let's have a look at this one, 7 over s plus 8 to the 4. So this time, using our generic formula, our c will be 7, our a would be minus 8, and our nth power, or indice here, is 4. So n equals 4. So now using our result, we've got c, which is 7, e to the at, so it's e to the minus 8t, and then t to the n minus 1. So n minus 1 is 3, so that's t cubed. And then we divide that by n minus 1 factorial, so that's 3 factorial. Okay, so now I can rewrite this as 7t cubed and divide that by, well, 3 factorial is 6, and e to the 8t I can put in my denominator. So 6e to the 8t. So that would be my result for my B. Okay, now what about this one? Now here we've got introduction here of pi and 2e. So this one here, just a slightly more challenging look than what the first two are. So here our constant c is pi, c equals pi. Our a, that's this one, well, as it's a minus sign, our a is positive 2e. And n is this power here, which is 3. Okay, let's follow this result here. So c is pi, e to the at, so is e to the 2et. So that's an interesting look. We've got e and an e here. and t to the n minus 1. Well, n minus 1 is 2, so in this case that's 2, so we've got t squared, and then divide that by n minus 1 factorial, so that's 2 factorial. So we can simplify this off as t squared and the pi, so I'll put pi there, and then e to the 2et divided by 2. So that'd be my result for this one. And then what about this one? Well, this one I've got e cubed in my numerator, s minus 3 pi squared, so I've got another squared term here and a 5 term here. So this one looks a little bit more challenging. So sticking with our generic formula here, c would be e cubed. My a, which is a minus sign, so I've got minus 3 pi squared, so a is just 3 pi squared. So that's going to be somewhere near 30, just under. And 5 is my indice here, so it's my n equals 5. Okay, now using this generic result here, c, that's e cubed, e to the at. So now I've got e to the 3 pi squared t. So e to the 3 pi squared t. And then t to the n minus 1. Well, n minus 1 is 4, so I've got t to the power of 4. And then divide this by n minus 1 factorial. So 5 minus 1 is 4, so it's 4 factorial. So that's that. So now let's do something with this. So here I can write t to the 4 at the front. And now I've got e to the 3 pi squared t. So I can rewrite that if I like as e to the 3, 1 plus pi squared t. That would be 3 plus 3 pi squared t. That would be the same. And then my denominator would be 24. So that would be my result for my ds. Okay, so that there is my 4 results when we have a question in this kind of format.